Welcome back. This is lesson 2, wave types 1.2. Last lesson you took your heart rate, and the point of taking your heart rate was to learn how to calculate frequency or cycles per second. First we took our heart rate for 15 seconds, then took that number times 4, giving me beats per minute, then divided by 60 because there's 60 seconds in a minute, and I would get my heart rate per second. Frequency is an important term when you're talking about waves. For example, this woman is speaking and creating sound waves. I could take a point in the wave, say right here, this crest, and I could count how many times waves passes by, and I could calculate this woman's speech frequency. Today's focus question is, what defines a wave? So in other words, we are going to learn about its properties and parts. In a moment, you're going to see my children making different spring waves. They're going to be using a slinky. If you've got a slinky at home, it would be fun if you would do this lab along with us and somebody in your house can help be the other side. If you don't have a slinky, you can participate in the next type of wave called transverse wave by making waves with a rope, a string, an unplugged vacuum cord, something like that. Let's get started. This first type of wave is called a compression wave. Compression waves have another name, and it's important that you be able to go back and forth. Whatever Mrs. Mott, Mr. Kennard, or Mr. Bradshaw say compression wave, we're also talking about longitudinal waves. So make sure they're used in conjunction. The wave moves in the same direction as the spring. So have a look at this video showing you what a compression wave looks like. Slow down. A couple things I want you to notice about this still picture. My son Corbin over here on the right is called the wave maker. So he is the wave maker, and he is the one that is pushing and pulling the slinky. My daughter Hannah over here is called the anchor. She is not supposed to move, but rather just hold her hands still for the waves to bounce off of. I can see clearly in this picture some wave parts. For example, right here where Corbin is starting to push the wave, that part right there is called a compression, and that's where they get their name, compressional waves. And this part right here that looks spread out, where the energy is not, that is called a rarefaction. This wave is also called a longitudinal wave because it is moving in one direction like this in a longitudinal pattern. And compression, rarefaction, and longitudinal can easily be seen in the way that it looks. I'm going to hit play again, and I want you to pay attention to where the blue duct tape is added to the spring. What happens to the blue duct tape as Corbin pushes and pulls on the slinky. More slow. Slower. There. Now stop and pull it back. And go. And stop. So this is kind of ironic, but yes, I want you to reflect on the compression waves, and I think the answers to most of these questions are going to have the words reflection in them. And to reflect means to bounce back, to look back. So bounce back. Please take some time in your guided notes to answer these questions right now. What happened to the masking tape flag as Corbin pushed and pulled? Where did the masking tape flag end up when I finally asked him to stop? Where was it? When you made a single compression wave, what happened when the wave reached the end of the spring? And finally, this question you can't quite see in the presentation, but did the entire strength of the wave reflect, or was some of it lost to Hannah? Think about these questions and write down your predictions, or reflect on what you saw. This is where you get out a slinky if you've got one and try getting a rhythm going with the pushing and pulling of the compression waves. So you'll have the wave maker kind of set a rhythm like 1 and 2 and 3 and 4 and a flagger would be somebody that stands off to the side and watches the little flag in the middle. And then take turns rotating, let somebody else push and pull the flag, or push and pull the spring, rather. If you don't have a slinky at home, it's okay, you saw it in the video, and you'll be able to participate in the next type of wave. So when you participated, was there any reflection in the series of compression waves? Think about it. All waves have two things in common. The first thing they have in common is that they move back and forth. Doesn't matter what type of wave, but they move back and forth. So in this direction was where Corbin was sending the energy to Hannah, but they also transferred energy. You might remember that the compression that was here and here eventually reached Hannah. So they carry the energy that was from Corbin's hand. His hand was creating the energy here, and the energy traveled down the arrow to Hannah, and then it bounced back and went back to Corbin. And that bounce back, can you remember what it's called? It was called reflection. So all waves can reflect. As you learned from the previous module, the energy of motion is called kinetic energy. And Corbin was creating kinetic energy in the spring, and it was in the form of a compression wave. He was making compressions that went back and forth, bouncing and reflecting off Hannah's hand. The other type of wave is called a transverse wave. We still have an anchor over here, and we still have a wave maker over here, or vice versa, it doesn't matter. And the wave maker will start making the waves, but I want them to be serpentine like this, like a snake. This is where I asked you earlier to possibly get out a rope or a slinky if you've got one, or the cord of a vacuum that is unplugged, somewhere where you can make waves with a long cord. Did you have time to read? Anchors, wave makers, flaggers all have jobs creating side-to-side motion. Make sure you take turns, but I want you to observe how the energy reflects off the anchor. Later on, I'm going to ask you to label the parts of a transverse wave because there are more parts than in a compression wave. And so stay tuned for the labels, but this is the type of wave you're going to be making. Now Hannah.
He did it at the same time as me.
Okay. Now I'd like you to experiment with the dimensions of the waves. First, start with a repetitive pattern like we did before. Keep the same rhythm, 1 and 2 and 3 and 4 and make sure that the anchor doesn't move like you saw in the video. Also, make sure you try to speed up at one point, slow down at one point. Try making waves that are smaller in size versus waves that are larger in size. You also should try to create what looks like a standing wave, and what I mean by that is one that looks like it's not moving. So a standing wave, it looks like it's standing in place. I'll show you in a second what I mean. We're going to learn two parts to the transverse waves coming up. I bet you can figure out where they are, crests and troughs. Please complete part A of the notebook sheet after you experiment.
Slower, slower, little and fast, little and fast, little and fast, little and fast, little and fast. There you go.
You you might have noticed at the start of the video when they were trying to keep the same rhythm that it looked like this picture here, like a standing wave. The crests and troughs always ended up in the same place. So again, it was always in this pattern, about one wave per table. And then you might have noticed as I asked them to go faster that there were more waves like this created if they move littler and faster. So I want you to try these patterns as well. Experiment with how many different waves you can get in a certain amount of time, and make sure you try to practice a repetitive motion like in music. Keep the same rhythms. Here's a better demonstration of a standing wave. So now it's time to get a little bit more technical with your experiment. I would like for you to create a wave, say on a table or a hard surface on the concrete outside. And I want you to just focus on a transverse wave. So let's pretend this is our transverse wave right here as I'm going to draw it. Okay. And you're going to focus on the parts of the wave to start. So I would like, as you're making the wave, and you try to make a standing wave, one that looks the same each time. So if I were to draw its opposite, it would look like this, as the energy is moving down to the anchor, okay? And I would like for you to, the flagger, to start marking some things. First thing I'd like you to mark is what is called the crest. The crest is the top middle of the hill, if you will, or the crest. So I would like for you, as you're making the wave, for the flagger to take a piece of tape or something to mark where the crest is happening, okay? And the crest hopefully will only occur once or twice as you try to create a standing wave. The next part I'd like you to mark is called the trough. Sounds like the word cough, but it's trough, okay? And it's the lowest part of the wave. So in this picture, here's the trough. So again, flagger, go ahead and put a little piece of tape or something on the ground or table where the trough is hitting in your standing wave. Okay, the next thing you're going to do is keep an eye on the anchor and the wave maker and make sure they are exactly across from each other. And with a piece of tape or a pencil or chalk if you're outside, draw a line across like this. This is called the standing line or the midline. The reason you have to have the midline marked is so you can label this next part. The next part is where the wave intersects the midline. So here, and here, and here, and here. And these things are called nodes. N-O-D-S. Sorry, N-O-D-E-S, or nodes. The nodes are where the energy comes into contact with the midline. Okay, so I've got some parts so far. I've got a crest, the top, a trough, the bottom. Nodes are where it intersects the midline. And there's another part that we definitely need to know for this coming up lab. And that is the part where I go from the rest line up. The rest line up is called the amplitude, or the height of the wave. Amplitude. So notice when I drew amplitude, I started from the crest and drew a line down to the center line, but it's exactly in the middle. That is how I measure amplitude. One more part. The last part that you need to know about the wave, and probably the most important part, is called the wavelength, how long a wave is. There are several ways that you can measure a wavelength. One of the first ways to do that is to measure the distance from one node to the second node. So this distance right here times 2. The reason that one is the easiest is because I can easily see where it intersects the line and then just take that amount of measurement times 2. A second way to measure wavelength is like this. I'll draw a second line down here to help out. A second way to do it is to measure from the first node to the third node, bypassing the multiplication. So first node to third node. Another way to measure wavelength is from crest to crest. It's just difficult to find the exact peak. So sometimes we don't encourage doing crest to crest unless you have a really good flagger to mark it. And finally, you can mark from trough to trough. All these ways to measure wavelength are just fine. Once again, first node to second node times 2. First node to third node, no multiplication needed. Crest to crest, or trough to trough. Wavelength is how long one wave is, and you can see that it is one wave when I mark these parts. Now it's time to begin your lab. You're going to make a series of transverse waves, like I had described, marking things with pieces of masking tape. You are going to need a ruler, but you have a ruler for math class. You also have one in the back of your planner, a plastic ruler back there to use. And you are going to follow the directions using the new vocabulary that I've taught you. So you're going to use vocabulary like amplitude and crest and wavelength. Okay, you're going to learn some new vocabulary like velocity, but don't worry, you're going to learn how to do velocity with this equation. You already know how to find frequency, count the number of cycles that come by. So all of these are things that you're going to do step by step by yourself and with a partner. As you're making waves and taking data down in your lab, talk about what all waves have in common again. What back and forth pattern do you see in the transverse wave? What energy did the transverse wave transfer? We know the answer to these, that all waves are repetitive, that they move because of kinetic energy, and that all waves reflect. So you can see that easily in this lab. Those are some of the characteristics of waves. But also, most importantly, is how to measure these characteristics using the new vocabulary that we've just talked about. If you need a reference sheet to always look at, go to your purple book and turn to page 81. 81 has all the parts marked for you, and that way you can have the flagger look carefully at the parts and mark them with tape. Don't forget to use centimeters as your distance as stated in the lab. It's time to reflect in our guided notes. What are the 2 types of waves that we created today in class? What are their names? What do these kinds of waves have in common? I would like for you to come up with 3 characteristics that they have in common. And how are these waves different? Go ahead and write in your notes. Mrs. Mott, Mr. Kennard, and Mr. Bradshaw will comment on your ideas in the comment section if there is any trouble we see. Now spend a few times reviewing the vocabulary. You will use the back of your purple book in the glossary to find the definitions of these words. Then, instead of drawing a picture this time, I would like you to use the words in a sentence. So 3 parts. Word, term, then definition, then use the word in a sentence. You got quite a few vocabulary words. Take your time. So, what defines a wave? What kinds of characteristics do all waves have? What are their parts? Make sure you have thoroughly gone through the lesson, nice and slow, and that you could identify the parts of the waves and the types of the waves when presented in the next lesson.